Okay, now this is the tough one. This is the one that I starred and I said difficult. If you mastered lesson 6 from chapter 3, which was the solving a system of equations with 3 variables, then this is going to be easy. But it's just one extra step on top of solving a system of 3 variable equations. So we're given a quadratic function, or potentially points of a quadratic function. And so we have to go back to function notation of a quadratic equation is that. So what we can do here is, and remember, I should say f of x and y are the same thing. So when I plug these values in for x and y, I can see what the resulting equation is. So I'm going to do that for 1, 0, 2, negative 3, and 3, negative 10. So that's going to be 0 because, or f of 0, which we've already established as y. Okay, so that's 0 equals a times 1 squared plus b times 1 plus c, which if simplified, it's going to be 0 equals 1 squared is 1 times a is 1a plus 1b plus c, because we don't multiply c by anything. We do the same thing here. Plug 2 in for x and negative 3 in for y, or f of x. And we'll have a times 2 squared plus b times 2 plus c. So we're going to have negative 3 equals 2 squared is 4, 4 times a is 4a, plus 2b plus c. And then for this last one, we're going to have negative 10 equals a times 3 squared plus b times 3 plus c. So here we're going to have negative 10 equals 3 squared is 9, 9 times a is 9a, plus 3b plus c. Okay, so here it is. There is our system of equations. So now we basically go back to what we learned in lesson 6, and we solve that system. Now, because none of these values are just AB equals 2 or A equals 3, we can't use substitution. So the best method to use here is probably going to be elimination. So in this first equation is super easy. A plus B plus C equals 0. So I'm going to pair this equation with the second one and the third one. And I'm going to solve by elimination using those 2 methods. So I'm going to have A plus B plus C equals 0 and negative 3 I changed it around because I like my equal sign on the right hand side. 4a plus 2b plus c equals negative 3. And then I'm going to pair this up. A plus b plus c equals 0 and 9a plus 3b plus c equals negative 10. Okay, so there's our pairs. So remember, to solve by elimination, whenever we solve a system of 3 variable equations, we need to get rid of one of the variables. I am going to use c because they are the exact same. Whenever you do this, it's always going to be easiest to do c because it'll always be plus c at the end of no matter what equation you have. The only thing is we need it to cancel. So we're going to have to multiply one of these equations by a negative to make it cancel. I'm going to pick the first one, again, just because it's easy. So I'm going to multiply this entire equation by a negative 1 for both of these to make the c's cancel. So I will actually have negative a plus a negative b plus a negative c equals 0, because 0 times negative 1 is still 0. So this is gone. And I now have that, which when I add, we'll get 3a plus 2b equals, because that will cancel negative 3. And then here we can do the same thing, multiply the first equation by negative 1, so we'll have negative a plus a negative b plus a negative c equals 0. Again, add, so we'll have 8a, right, because this is gone. We multiplied by -1, and that created this equation. So that equation doesn't even exist anymore. So we have 8a plus 2b, those c's cancel, and that equals -10. Now I have a system of two variables, right? So now we can solve that system. Let's see if, no, it doesn't let me move it. So that system is going to be 3a plus 2b equals -3, and 8a plus 2b equals -10. Again, here we kind of luck out because I have two variables that are the same, but they just don't cancel yet, so I need to make them cancel, and do that by multiplying one of our equations by -1. I'll multiply the first one by -1, and that will give me this new equation of -3a minus 2b equals +3. So this, again, doesn't even exist anymore because we multiplied by -1. So now we're going to add, and we get 5a, the b's cancel, equals -7. That didn't work. What did I do wrong? Oh shoot, this was just 1b. You probably realized that in the video a long time ago, didn't you? So that's 1b, so that's going to change all this. So I'll have 3a plus 1b equals -3, and 8a plus 2b equals -10. So this is not as easy as just multiply 1 by -1. I'm going to multiply this by -2 to make my a's cancel. Or sorry, to make my b's cancel. Could I multiply to make my a's cancel? Yes, I'm just going to have to multiply both equations, so that's going to be a little bit more work. And I always like to do less work when I can. So we'll have -6a minus 2b equals +6. So again, this first equation is gone, leaving us with 2a, the b's cancel, equals -4, and a is -2. So we have what a equals. So now we take that -2 and we plug it in to one of our two variable equations, or here, and solve for b. So I'm going to plug it in for a here. So I'll have -6 plus b equals -3, add 6, b is +3. So I have a is -2, b is +3, so I'm going to take both of those values and plug them both in for one of my three variable systems up here. And again, I'm going to pick the first one because it's easiest. So I'm going to have -2 plus 3 plus c equals 0. So I'll have 1 plus c equals 0, so c equals -1. So my quadratic equation that those 3 points represents is f of x equals, or y equals, -2x squared plus 3x minus 1. You might say, how did you know those numbers went there? Because ax squared. Since a was -2, it's -2x squared. Since b is 3, it's 3x. Since c is -1, it's just -1 there. So this would be the quadratic equation that those three ordered pairs represents. Sorry for the mistake, but if you have any questions on this, make sure you bring it in and ask tomorrow. Have a nice day.